Hello, everyone. Good evening, and welcome to yet another Unacademy's session. And my name is Nikunj, and I'll be taking a physics lecture in today's class. And trust me, I can bet on this that this lecture will be a very, very interesting and a very beautiful lecture from the JEE Foundation point of view, or you can say if you're anywhere in grade 9 to grade 12th, this lecture is a very, very important, a very, very crucial topic for all of you. All right. So which topic are we going to start today? It's basically the topic known as the Newton's laws of motion that we'll be discussing in today's class. So welcome again, and you can tighten your seatbelts to get started with today's very interesting and a very fascinating class, as well as a very fascinating idea about the laws of motion, the laws that govern the movement of any and everything that you see around you moving, right? That means anything that you see that is in motion or is moving around yourself, it has to follow a certain law, or I would say a certain set of laws, which we will be discussing in today's class. So let's take up the topic for today's class, and that is the laws of motion. But before we move to laws of motion, first of all, we need to understand what exactly is motion. What is motion in the first place? So let's understand about motion before we move on to the laws of motion. All right. So I'm going to ask everyone, what do you know about motion? How do you define it? What do you know about in layman language? What do you say motion is? Anyone here who can answer that? I'll be watching the chat windows. You can put your answers in the chat windows as well, or you can, yeah, there's only one option, right? You can put your answers in the chat window. I'll be watching it in the chat window. What, according to you, is motion? All right, so I've started getting some responses. Very nice. Very nice. Very good. I can see a lot of very close answers, but none of them or none of you have answered it to the point till now. What is motion? Very nice, very nice, very nice. Thank you so much for the responses, everyone. So let's understand what exactly is motion. Motion is basically the change in position of an object with respect to, now I'm only writing the acronym for with respect to, WRT. Please be mindful about that. WRT is just the acronym for with respect to. It's, now these are the two important words in the definition: surrounding or the time. What do we mean by that? Why are we taking the references as surrounding or time? So first of all, let's see the definition. Change in position of an object with respect to its surrounding or time. That means whenever an object is changing its position with respect to its surrounding or the time, right? For example, let's say there is a car moving. Now, what all things would be the surrounding of the car? Let's say there is a tree here beside the car, right? So the tree is one of the surroundings of the car, or you can say the tree is the surrounding of the car. Now, if the car is changing its position with respect to this surrounding or the tree, then it is said to be in motion. If not, it is at rest. Very simple. That means if at one point of time the car is here, and on the other point of time, or the other point of time, it has moved here. That means with respect to the tree, the car was behind the tree, and after some time, it has come ahead of the tree. That means with respect to tree, the car has changed its position. So we can clearly say that the car is in motion with respect to its surrounding, of course, right? Also, you could have said it in terms of time or with respect to time. Let's say at 11, what is the time? It's 4:45 as of now. So at 4:45, the car is here. Oh, here, right? And after 1 minute or after 2 minutes, let's say the car has reached this place. That means with respect to time, the car has moved or it has changed its position. So we can say that the car is in motion with respect to time. Now, you might say, sir, why are you complicating things? Why do we need these with respect to surrounding and with respect to time? Can't we simply say change in position of an object is motion? Why do we, for no good reason, complicate the definition or make it lengthy by including those words surrounding or time? Can't we simply say change in position of an object is motion? Well, we cannot. Why? Because motion or rest both of them are relative. Now, what do we mean by relative? Relative means these words are only defined, or you can say completely defined, only when you define them with respect to an observer, or in technical terms, we call it the frame of reference. What is frame of reference, sir? I did not understand. It looks a very difficult word or a very big word. So, students, do not worry or do not look at the complications that you see in your life. Always look at the solutions to those complications. Frame of reference is nothing but observer in layman language, right? Observer. According to me, something is in motion, but it's according to me. For you, the same thing at the same time might not be in motion. It might be at rest. That is what it means, right? So that is motion and rest. Now, yeah, and of course, I do not need to tell you all this, but then still, what is rest? It's simply put a no and copy the definition of motion. No change in position of an object with respect to its surrounding or time is what is rest. Very simple, right? So that is motion and rest. It's just a recall of the things that we already know from the previous grades, right? So I'm not going in a lot of depth. It's just a recall. We are just building up the context for Newton's laws of motion. Now, the next thing that you should know before moving to Newton's laws of motion is what a force is. What exactly is a force? Force, if you go by the definition of the book, is a push or a pull on an object. That means whenever you try to push something or pull something, you are basically applying force. We all know this, right? And the SI unit of force is also known to us. It's Newton. Sir Isaac Newton. But if you have already marked, or if someone has marked, I have made a mistake here. The mistake is I cannot write the SI unit with a capital letter. Otherwise, that would be the name of Sir Isaac Newton. If I want to refer it to as the SI unit, I need to write the N small. But when I symbolize it, I can write it capital N. These are some of the rules when you write the SI unit. Anyway, force is a push or pull on an object, and the SI unit is Newton. Now, what are the effects of force? What all effects can force have? Effects of forces? Anyone, any idea? What all force or what all effects can a force have? Have you ever applied force on something? What do you see happening? Or what all effects could the force produce on the object on which you applied the force? Anyone, any idea, rough idea? Put in the chat windows. All right, started getting responses. It could move the object. Very nice. It could change the shape of the object. Very nice. Very good. That means there are a total of 5 effects that the force can have, everyone. Please take a note of it. The first effect is force can change the state of motion of an object. It can change the state of motion of an object. Second, it can change the direction of motion of an object. Third effect, it can change the speed of motion of an object. Right? So these are the effects that the force can have on the motion of an object. Of course, it can have some other effects as well, like it can change the size and it can change the shape of the object. But we are not worried about the shape and size as of now because we want to relate force with motion. If you see the 2 slides that we have learned here, motion and force, you could see are related to each other. How? That means a force can produce some effect on the motion of an object. It can change the state of motion of an object. It can change the direction of an object, or it can change the speed of motion of an object, right? That means a force can cause a stationary object to move, and it can also at the same time stop a moving object. What do I mean? Let's bring in the object. So you can all see this object on my hand, right? It is at rest. It will remain at rest throughout its life until I start disturbing it with a force, and the force could move it. That means you require a force to move an object, right? Now you might say, sir, this is very obvious. Why are you telling all these things? Come to the point. Let's discuss Newton's laws of motion. Newton's laws of motion is the toughest part. It's very tough. It's something that's very important. What are Newton's laws of motion? Why? These are very simple things. We know that you cannot move something without pushing something or pulling something. We know this. Well, guys, Please be noted that this is what is Newton's first law of motion. Let's understand Newton's first law of motion. And if you look at Newton's laws of motion in that concept or in that perspective that I've just told you, you'll see all the laws are very easy. Newton's first law of motion. What is Newton's first law of motion? The statement, if you go by the statement, it says that I'm going to say the statement very fast. I know all of you already know it, but the statement is not important. The explanation to the statement is very important, right? So Newton's laws of motion. What is the statement? The statement says that an object at rest or in uniform motion will continue to remain in the state of motion or the state of rest until and unless an external unbalanced force is applied on it. What do I mean? That means if there is an object that is at rest, or if there is an object that is in uniform motion, please be noted, it's uniform motion and not any kind of motion. It has to be specifically uniform motion, right? So an object at rest or in uniform motion will continue to be in the same state until there comes an external unbalanced force. And that is what we just said, right? That if this object is at rest, it's going to keep being at rest until there is someone to disturb it, a force to disturb it, to be specific, right? That is what is Newton's first law. That's very obvious, right? We already know it. It is just that it has been postulated by Sir Isaac Newton into a law. Therefore, we know it as Newton's first law of motion. Otherwise, there's something that is very obvious and we already know it, right? So that is Newton's first law of motion. Now, again, all the brilliant minds here in the class might ask, sir, again, you are complicating things. That time you introduced surrounding and time. Now you have introduced two new words, external, unbalanced. Why can't we simply say force? An object is there, it will remain at rest. If I apply force, it won't remain at rest. So simply say force. Why are we calling external unbalanced force? Everyone, I'm going to ask you a question. Tell me the answer to this question. Let's say, I don't want this to happen ever with you all, but let's say you are into a beautiful road trip, but then the car suddenly broke down. The car is no longer moving. There is some problem with the car. What you'll have to do, you'll have to push the car all the way to the nearest garage and get it repaired. Now to push the car, I'm going to give you two situations. Let's say in the first case, you are pushing the car while sitting inside the car. You are one lazy lad and you don't like to come out of the car. You're simply sitting inside the car, folding your hands, and then you're trying to push the car from inside. What do you think? Will the car move by an inch? You have this in your intuitions, right? Intuitively, you know that the car is not going to move. No matter how much you try, from inside, if you push the car's not going to move an inch. But as soon as you come out of the car and try pushing it from the behind, you will understand and you'll know and you'll realize that the car could easily be pushed to the garage. That's the power of external force. When you are inside the car, you are applying an internal force because you are inside the system or the car. We'll learn about it. So when you push the car from inside, you are applying internal force. And please be noted that the internal forces can have no effect on the motion of an object, at least till now. In later classes, we'll learn more about it. But external force can have it. Therefore, it's very important to mention that the force has to be external, not internal. Similarly, balanced force can have no effect in the state of motion. Unbalanced force can have it. All the curious minds here, please go and search about balanced and unbalanced forces if you do not recall it. But this is something that is there in grade 6th, grade 7th, grade 8th. Okay. So if you not recall, go and search about it. You'll recall. It's a very easy concept. That is Newton's first law. That means you need an external unbalanced force to make a object at rest move or bring an object in uniform motion come to rest, right? That is what Newton's first law of motion is. So it clearly says that you need a force to change the state of motion. Very simple. In one line, this is what it says. You need a force to change the state of motion. Okay, sir. Understood. आ गया समझ कि न्यूटन्स फर्स्ट लॉ कहता है you need a force to change the state of motion. Now what? Now you need to calculate that force, right? So the first law tells you that you need a force. The second law comes to rescue when you want to calculate the amount of force. So the Newton's second law of motion, it basically tells you how much force you need. First law tells you you need a force. Second law tells you how much should that force be, right? So before we move to Newton's second law, there is one very important concept that you should recall, not not understand. You already know this. You have already understood it in lower grades. You need to revisit and recall this. What is momentum? Represented by P. Momentum is mass times velocity. Please recall, everyone. Momentum is mass times velocity. That is momentum. Now, let's come back to Newton's second law. Okay, sir. First law tells you need a force to move an object. Second law will tell you how much is that force. How? Kaise, sir? So force is equal to, according to Newton's second law, force is equal to the change in momentum over time. Sir, ye delta, as soon as I see delta, I get confused. Delta is nothing, everyone. Delta is simply a change. Whenever something is changing, we write it delta of that particular thing, right? Here it's momentum, so it's delta P. That means a change in momentum, right? So this is rate of change of momentum. Now you might say, sir, हमने तो Newton's second law, force is equal to mass into acceleration पढ़ा है. I know that force is equal to mass times acceleration is Newton's second law. Now, why are you confusing us with a new formula that we have never seen? Well, we'll come back to that formula. Don't worry. As of now, let's see this. Force is equal to change in momentum over time. Now, everyone, how do I find out change in momentum? What is change in momentum? Let's understand. Suppose I have bought something from you for 20 rupees and I gave you a 100 rupee note. How much would you return me? All the geniuses calculate and tell 80 rupees, right? How did you find that? 100 minus 20. So the change is 80. How did you find the change? By subtracting the final value with the initial value. So that is how you find the change. Change in momentum is the final momentum minus the initial momentum. That's the change in momentum over time. Now, everyone, momentum in terms of mass and velocity. Let's write down. Final momentum will be mass times final velocity. Initial momentum would be mass times initial velocity over time. Right? Now, can you see mass common in the two phrases there? So it's V minus U that is left over T. And if you cannot recall already, let me tell you, V here represents the final velocity and U here represents the initial velocity, initial one, right? So V minus U over T. Now, you might say, sir, ye dekha hua lag raha hai. I've seen this formula somewhere. V minus U over T, what is that? What is V minus U over T, everyone? V minus U over T is the rate of change of velocity, which is nothing but acceleration. And that is the most commonly known way for Newton's second law of motion. People remember Newton's second law of motion as force is equal to mass into acceleration. Actually, it starts from force is equal to rate of change of momentum. And trust me, this particular formula sometimes can have more applications than that formula. Force is equal to mass into acceleration. Kaise, sir? We have seen mass into acceleration being used in a lot of places. I've never seen delta P over T being used. Let's see. Let's understand. How do you use that formula? Please look at the formula again, everyone. F is equal to delta P over T. That means wherever there is a change in momentum, the rate of that change of momentum would be equal to force. That means it's directly proportional to the change in momentum and inversely proportional to the time taken for the momentum to change. Please note, everyone, please note, T there, the small t that you see, the time there is basically the time required for that momentum to change. That means, let's say if the momentum is changing from 10 to 5, I'll repeat. Let's say the momentum is changing from 10 to 5. ये 10 to 5 2 सेकंड में भी हो सकता है, 3 सेकंड में भी हो सकता है, 4 सेकंड में भी हो सकता है, 5 सेकंड में भी हो सकता है. It can happen in any time, right? So the amount of time that is being required to change the momentum from a particular value to a particular value, from final momentum to the initial, from the initial momentum to the final momentum, right? So that is what is T. Now let's look at the applicability. Let's say I have two surfaces. One is how do I say that? One is cushioned surface, a soft cushioned surface, and the other one is a hard surface, right? Cushioned surface, the hand in which I'm wearing the watch is the cushioned surface, and the other one is the hard surface. Now, let's say I have a glass of water bottle here. Can you see the glass? I hope you can see, right? And this is purely made up of glass, right? Now, if I drop this glass on these two surfaces, you might say, sir, mat karna, mummy bahut chillayegi, right? But trust the science. So let's say I'm dropping this bottle on both the surfaces one by one. First of all, I'm dropping it on the cushion surface, and in the other case, I'm dropping it on the hard surface. Where do you think will the glass break? On the cushion surface or on the hard surface? Definitely the hard surface. But have you ever asked yourself, why? Why not on the cushion surface? Well, the answer is second law of motion. What is happening is, when you have the bottle at a height, it has an initial momentum, 0. And when you drop it, it starts gaining the momentum because it's gaining velocity. As soon as it hits the ground, its momentum is changing again. But in the cushioned surface, it's taking a lot of time to change that momentum. Why? Because it will sink first and then bounce. So there will be enough time for the momentum to change. That means you have good amount of time in cushion surface, and you can see it clearly. Force is inversely proportional to time. If the time increases, force is gonna reduce, and if the force is reducing, the glass won't break or the bottle won't break, and mama mujhe nahi chillayenge, right? So that is how the Newton's second law of motion can be brought into application. There are a lot of other applications as well. For example, if anyone here is a cricket enthusiast, you might have seen players or cricketers. When they catch the ball, they drag their hand down along with the ball. They'll drag their hand down. They'll catch it like this. Why? It's because they are changing the momentum. The ball is coming with a great velocity, and they know they need to stop it. That means they need to change the momentum. They are just giving enough time for the momentum to change so that it doesn't hurt their hand with a great amount of force, right? You might have seen athletes. Athletes usually jump on a floor made up of sand. Why? Same concept, cushioned surface, sand, almost the same thing, right? So that is Newton's second law of motion. That means first law told us that you need a force. Second law could calculate the amount of force. Third law finally tells you the effect of that force. Newton's third law of motion. It tells you what happens once you apply that force. So what is the third law? Very common and a very, very beautiful law, which says that to every action, there is an equal and opposite reaction. To show the opposite sign, I'm going to just put a minus here, but that's not how it is written technically. It's just for the explanation. So to every action, there's an equal and opposite reaction. Sir, matlab, that means when you punch a wall, you get hurt. Isn't it strange? You are punching the wall, so the wall should get hurt. Why are you getting hurt? That is because when you apply a force on the wall, according to Newton's third law, the wall is gonna apply a force back on you, right? And that force will be equal in magnitude. That means agar aap 2 Newton lagaoge, it's gonna apply 2 Newton back. Isliye when the harder you hit the wall, the more you get hurt, right? Because the wall will apply an equal and opposite force back on you, right? So that is Newton's third law. Now there is a very, very common mistake that the students make here. What they'll do is, sir, action reaction pair equal and opposite, therefore they should cancel out. Two forces only cancel out when they are acting on the same body. 10 Newton, 10 Newton. Here you can say that they are cancelling out or balancing out each other. Very simple. But look at that part, that diagram. There is a force by the hand on the wall, and there is the second force by the wall on the hand. So there are two different objects involved. You cannot cancel the action reaction pairs like that, right? So that's a very big misconception that the students go through. Please be mindful about that. And that brings us to the end of the session. That is the three laws of motion that we've discussed. So please remember, Newton's first law tells you that you need a force to change the motion. Second law tells you how to calculate that force. Third law tells you the effect of that force once you start applying it. Right? Thank you so much for bearing me for 1 hour. I hope you liked it. I hope you enjoyed it. I'll see you soon in the next class. Till then, bye-bye. Take care. Keep learning. Hasta la vista. Adios. And have a very, very, very fine day ahead, everyone. Keep learning and keep growing. Thank you.